Swayam Prabha. Digital India. Educated India.
So, you have to map it in a pure shear, there is no normal stress, and in pure shear only the wet friction governs. Okay. So, that is some of the observations you have to make in here. Okay. The final criteria that we want to look up is the Drucker-Prager criteria. What this tells us is this similar to Mohr-Coulomb's criteria, except that it places in terms of the invariance directly. Okay. We saw that K to D is nothing but the octahedral shear stress. We want that to be lesser than some kappa square. Okay. This is like a wet friction similar to the C that played a role in Mohr-Coulomb criteria minus K1, this is the first principal invariant of the stress, that is there is nothing but trace of sigma, which we saw is related to the hydrostatic pressure. Okay. Trace of sigma by 3 is the hydrostatic pressure. So, it is minus K1 times some factor alpha. This is what the Drucker-Prager criteria tells us. Okay. This alpha is like a dry friction coefficient that comes in the Mohr-Coulomb criteria. Okay. We will not go into more details of these failure criteria, which we will go in more detail in either soil mechanics course or in advanced course in mechanics of materials. Okay. Okay. So, before finishing, couple of more points. First point is you have to understand that these failure criteria, there are many of them, because there is not one failure criteria that governs the failure of all materials. So, depending upon the material, first you have to choose the failure criteria, and then you have to find the parameters in the failure criteria based on a particular test that you do on that material. Second point is, it is possible for materials to have strength greater than the uniaxial strength of the material. Example, a pressure insensitive material like exhibiting von Mises failure criteria. If you see here, the ellipse will be such that if I join this line, in tension or compression, the strength exceeds the uniaxial strength of the material. So, it is possible that the strength can exceed the uniaxial strength provided you apply some small tension in the other direction. Okay. And by the way, what is this red envelope here? It is the Tresca envelope, which is inscribed inside the von Mises envelope only if I match with the uniaxial yield stress. On the other hand, if I match with the shear stress, the von Mises curve would be inscribed within the Tresca criteria. So, it is not that one failure criteria is always conservative and the other is unconservative. It depends upon where you are matching the failure criteria. Okay. And you have to be able to articulate where the maximum difference occurs in each of these failure criteria, Tresca and von Mises, Rankine and Mohr-Coulomb, Rankine and Drucker-Prager. In all these cases, you can compute analytically where the maximum difference occurs, even though they agree upon in the uniaxial yield stress condition. Okay. So, these are some of the pointers on what you can be tested upon in a failure criteria, or what you should be aware of in your designing structures where you want to prevent failure. Okay. Thank you.